Hi everyone, my name is Matthew Harrison. I'm a farming system scientist at the University of Tasmania. In this webinar I'm going to give you an overview of the functionality of DSAT, and I'm going to look at specifically version 4.7.0.0. So just note that carefully, because if you look at this webinar sometime in future, the version may change and the layout may change subtly. So the actual interface itself, when you open it up, you'll have something like this. There's actually a few components there, so it might seem like a lot of white space, but we'll just take a moment to go over these. You have what's called this selector. Now I've got the boxes minimized here, but there's a lot of information in there, and it's useful just to delve into that, and we'll look at that shortly. When you open up anything in this selector, it will pop up here with the file names, and it have different extensions depending on what the file itself is. You've got the size as well as the date it was created. When you click on them, the data appears down below here. Now this data itself is actually associated with something in this data file that I've opened, but that's useful for determining, well, for bug checking and for determining the actual format of the file that you're looking at. So if we just go to crops, we open up this here, you can see all the crop types that are available in the default interface. Now if we open up cereals, you can see that there's a bunch of different cereals: barley, maize, wheat, legumes, so on and so forth. And if we click on maize, for example, you'll see a bunch of different existing treatments come up. Now note that maize have this extension .mzed, which is MZX rather, which is good, which is intuitive. Then you've got a description. So this first one is irrigated maize and rainfall, when it was created, when it was modified. If I check this box here, it will come up with the treatments associated with that experiment. And if I pull this up, it's very useful in anything, in systems modeling in general, to label things in a long, without spaces, preferably, intuitive way, so that when you come back in 6 years' time, you can actually understand what it means. If you label it XZ1155, you might not know what it means, but if you label it irrigated experiment in Gainesville, Florida, with 2 levels of nitrogen treatment, you probably will know what it is. So it's very useful to label things as intuitively as possible. So here's all the treatments that are selected. Now if we go down here, we actually see the information that's used in the simulation. So the people, the address, there's some notes, which is really good to see. The actual data source, European Journal of Agronomy. Here we have the treatments. So 8 treatments in this one, some rain-fed and irrigated ones. Different factor levels, cultivar types or genotypes, fields, soil analysis, initial conditions, and you can go through that. So that's very useful to go through. Now some of them, some of the existing examples that is, if you click on them, they have outputs, so they've already been ran. So these are really useful for learning from. So if you click this one, this is an output, and so it's showing treatment number and some of the variables that have come out of the model. So it's that one's potentially maturity days. Negative 99 means the variable wasn't simulated, and that's the same as input variables. Then we've got outputs, and so you've got generic output files and experiment specific. Now we've got, so if we minimize that crops one, we've got applications. Now the applications is, you can select this in what's called the XBuild, which is crop management data, and we'll go into that in a second. So you can select a seasonal analysis. So you actually build a seasonal analysis using this crop management data one, and you run it using this seasonal analysis. Then there's a sequence analysis. Then there's a spatial analysis, which basically runs the model, which is a very useful aspect really of DSAT. So you can run the model at multiple different locations. Now if we click on one of these, it will come up with the treatments that have been run. And if you watched a previous webinar, you would have seen when I created these seasonal analyses, so on the 14th of September. If we click on this one here, this Thailand one, it's got a number of different treatments and then the information associated with it below. Now data, now I've got to have to be careful clicking here because some of these are really big databases, and if I click on them, it'll probably stuff up the whole webinar and the whole thing will pause. So if I click on soil, I'm not going to open that. Okay, it's already open. I might have already stuffed the simulation, but we'll just wait and see. So these are all of the existing soil files, and most of these, well, all of these are American. So you could imagine that WI was Wisconsin, TX is potentially Texas. So if we open up the weather file, so the daily one I know for a fact is a database, but it takes a long time to open. So I'm just going to see if I hold my tongue right here, this may work. So that did work. So it's got a bunch of different summary climate files, and again you can see the extension is different, .cli, the size of them. Click on this first one. It's saying where it was, so Alabama, USA, latitude, longitude, elevation, average temperature, amplitude, and so on. Then you've got your monthly averages, and that's useful to look at. So you might want to look at, for example, your month of the year, and then you've got your S aim in and then your X aim in. So I don't know what they are, so you may have to look up what the names of those variables are. If you can pick out and distinguish maximum and minimum temperature and rainfall, and you can look at these, you can actually get an idea of the seasonal climatic pattern. And that's useful for a check. So you can see whether rainfall and temperature are maximum in the middle of the year, which would be the case here if this was minimum daily temperature. And you can generally see whether rainfall is equiseasonal, that is, it's similarly distributed in each month, or whether it's increasing in one month, or something else. And that's a useful check for you to do even before you run your simulation. So close that weather one down. Then we've got genetics. So genetics itself is a very useful aspect of DSAT. We click on barley. We've got a number of different files here for barley that have already been created. So these are the cultivar coefficients, and so DSAT has different submodels for each crop type depending on which crop type you're using. For barley, it's crop sim series. Now these equations here are really just a vernalization or photoperiod equations, and so they're related to cultivar specific coefficients, and you can go into those or you can look them up, but you can actually see what they are here, so photoperiod, kernel number, and so on. So that's quite useful. We've got the genetics files for all of the associated crop types above. Then we have economics, so you've got economics associated with the seasonal, and you can again go into them there. You've got pests, so you might want to click on one of those, and it's useful just to have a look to see what's actually in there, to see what the model can do. So in doing that, you actually get a good overview of what the model can do without actually having to set it up and run it yourself. So it's really quite useful. So you've got here, we've got chickpea pest coefficients. So some of these might be a little bit difficult to understand, but usually by looking at the units you can sort of tell what they are. So that may well be leaf area duration in square metres per larva per day. Then you've got each of the different variables there, so whole plants, etc. And then we've got standard data. So that's again related to coefficients. That one there itself is, it looks to be a soil associated file because it's coming from Century, which is a soil model. So that's the selector. The selector's got a lot of existing example information and databases that you really want to look at before you start. Now, if we hit this button up here, configure, there's a couple of ways to do it. You can either do it in accessories and go to, or utilities rather, and go to configure, or you can hit this button up here. Now, I find this useful because it gives you really an overview of the whole functionality of DSAT. Okay, so it's got the system in here, so your profile, directory, you've got some options there, whether you want to show hints, so that's very important that that one's crossed. Debug mode, so you might want to have a look at that when you get a chance. You've got models, so you can manipulate where the models are coming from, whether they're enabled or not enabled, their extension, their directory. Then you've got your data, so you have soil data, weather, climate, generated weather, Just as a side note here, the difference between weather and climate is that weather is minutes to months. Climate is usually months to years. So climate is a long-term thing. You've got economic data, cultivar data, and monthly data. We've got tools, connection, so we've got some registration information there, and applications. Now applications is useful because it's really showing us what's in this menu here. So we have crop management data, the graph builder, soil, seasonal. So this is the main part that you use, tools. You may well use some accessories, although they're less used, as the name suggests, it's accessory. Then you've got manuals. Now these are very useful. So these are PDFs and they're actually in there, which you can look at. So I'm just going to cancel that. Now go back to tools. Now this is an overview, so I'm not going to go into too much detail because that would be a very long webinar. So each one of these first three goes into a separate little sub-program, if you like. So this one is called XBuild. This one is called GBuild for graph. This one is called SBuild for soil. So that really just builds a soil. This one here is experimental data and allows you to put in, for example, field experiment data on biomass or soils or soil water that you've measured. Weather data opens up a little sub-program and says welcome when you open. It's really, well, it's probably more advanced, I find, than many of the other components, or perhaps it's more recent. Then you've got the seasonal analysis, which allows you to look at multiple treatments over multiple years. Rotational analysis. Now what that really does is that you can look at the effect of sowing one crop type after another. So for example, double cropping, soybeans or maize, or you could look at sowing wheat after barley, then a fallow, then chickpeas, for example. Then you've got the genotype coefficient calculator, or GenCalc. Now that is used to estimate cultivar coefficients. That is unique to something in here, which is called GLUE, which is the generalized linear uncertainty estimator, which is used for selecting the experiments or the treatments that you can use to then put into this GenCalc. So those two the bits are closely related, but you use that glue utility first before you use this one here. So if we go into crop management data, we've got XBuild there, so you generally have these components up the top, so it's showing you the version there. You go to File, you can go to New, or you can go to Open, and so you can open an existing example. So if we just open one of these ones here, open that up there, it says reading the file, and then you'll see each of the components in them. So it's got the file name, the year. If they're blank, they'll come up with -99s, which means it's default. You've got environmental information, management information, and your treatments. Now I detail these in a separate webinar, so I won't go into these here. So when you've finished, you hit save, and then you hit save as, and then you hit exit. Right, now we go back to this one here. GBuild operates in a similar way, but it really just plots outputs after they've run. So if we hit GBuild, it's going to open up a file, an existing component utility, if you like. So if we hit open, and we go to one of these, so this won't work for all of them unless you've got a specific file. So what we're really looking for is T files here. So it won't actually plot anything else other than the T file that I've found anyway. It may well, but not that I've found. So if we open up maize and we use one of these examples, open this one here, it says loading GBuild. What comes up is your variables and your treatments. So it's useful before doing that to have a preview of your file. So it's got your treatment numbers down the left hand side, the dates and the canopy weights. It's got the time the file was last edited, as well as the site name, so we hit OK there. So we might want to look at leaf area index or leaf area index duration. Just click that one. Treatments, we want to look at them all. We hit next, and then we've got our treatments. So we've got date, and we've got the difference between treatments, which is quite useful for looking at, for example, a time series. And you can export that to Excel or do whatever you like. I'm not going to do anything there, so I'll just hit exit. So that's the XBuild, the GBuild. Now we've got the SBuild, which means build a specific soil file. Now that takes a little bit more time. That's a little bit more complex, a bit like the XBuild one. Read that very carefully because there's a specific sequence for which you have to open and close files. You can choose not to show the message again. I choose to leave it there because I think that's quite important because, well, you might have a better memory than me, but I forget. So I leave that message there so I can see it again next time. So if we can potentially, okay, so we're not going to be able to do it in this case, but what I had hoped to do was open. So we can go to new just to show you an example. And so similar to XBuild, it's got some of the general information there. Then you've got surface information. Now I suspect it won't let me do it. Yeah, it's wanting the number, but it goes into a second pane there where you enter your wilting point, your drained upper limit, your hydraulic conductivity and basic soil details, and you can enter that for each layer. You can then save it, and then you hit close. Well, I don't want to save it, and then you hit exit. So this is it's telling me to do this specific sequence that I told you about before. So please close the profile and then close the file. Okay. So we go to close file. You're about to close. Are you sure you've saved the changes? Yes, I'm sure. Then we hit exit. Now, experimental data is where you put in your field data. That's almost like a flash version of a spreadsheet, if you like. So that's mainly an input rather than a graphical thing. So you can, so you've got different tabs there, if you like, and you've got experimental notes. You can open an existing file and you can dump in data just to see how it looks. So if we go to barley, we go to this one here. We go OK, and it comes up with the treatment numbers. And if you hover over them, it's quite useful. Leaf area index maximum, number at maturity, so that's quite useful for actually understanding what they are. So we'll go exit. Now we go back to the main interface. So we've looked at these four. Now we go to weather data. Now this one here, it says welcome when you open, so it's whether it's more recently developed or not, seems to be more advanced to me. That might be more recently developed, might not be. And this is really powerful tool, particularly if you're looking at climate change, generating your own weather, comparing simulated weather to real weather, filling in gaps, stochastic weather generation. It's a really useful tool. Now it takes a little bit to navigate your way around this because there's a lot of components in the Weatherman. So you can open station, for example. So there's two existing examples in there. We'll open the Florida example. So in this one we've got observed, corrected and generated. We can open them all. And now it's saying, well, here's my location, my lat and long, elevation, my documentation when it was created. We have monthly means, which can be quite useful to check. So what it's showing here is that Florida is not winter, but tends to be rainfall dominant in July, June, August, which is the summertime in the US. Then we have temperature. So what's temperature doing? It's about minimum at the ends of the year and tends to be maximum in the middle of the year. That makes sense. So that's summertime. Same with minimum temperature, and that's good. So that's a useful check to say, well, it's actually probably reading the right data. The monthly average means are doing what we'd expect. Negative 99 means it's not measured. Then we've got the station climate summary, which is the climate summary for DSSAT. Then we have the observed weather. We have the corrected data. And we even have what's called the generated data. Now, in the context of this webinar, you can actually generate stochastic weather. Am I keen to do it here? I haven't used this feature for a while, so this is a bit of a risk, but we'll give it a go anyway. So you've got these four options. The default is to generate from calculated means and variances. You can generate with monthly means and stochastic rain, generate from monthly means, or generate to match a monthly time series. So really quite powerful, particularly if you've only got limited experimental data. So I'd encourage you to have a good look at these settings here, the settings as well as the different options in weather generation. So hit OK. Now it's obviously generating. So that could have been a substantial mistake to do in a webinar, given that it's only up to 19% and it's got to go all the way across to 100%. So we'll just wait for a moment. But while we wait, you can just see that there's quite a few components there. So there's properties, you can export, you can graph, you can update, you can scan. It's obviously got the different options across the bottom. So these are go back to the start, advance one, go all the way across to the end, add one, take one away, move up, hit OK, remove them or refresh. So it's actually quite a detailed little component in itself actually. So these are, it's ran and it's showing, so it's gone from the 9th of December, it's got rainfall, maximum minimum temperature and solar radiation. The G means generated, okay? So that weather, so it's gone down to the 31st of December 2007, we'll go up to the top, and it's from all the way from the 1st of January 1958. So it's a very long data set, and that's useful if you particularly want to look at seasonal climate variation, which is often what you want to do with crop models. And so there's a lot of other components in that, so you can actually look at the graph. So we can let's have a look at the observed data, graph the observed data. Just wait for a second for it to come up. And again, that could have been a mistake, but luckily it's worked. So we can look at rainfall. So we can see that there's measured rainfall in these periods and there's rainfall missing in these periods. So there's a big chunk there where rainfall is missing. On average, we're going from 40 to about 100 millimetres over time, which is really interesting to look at. If we hit graph back again here, we can see we're getting a monthly summary. So temperature is maximum in the middle of the year and least at the ends of the year. Note that that's not zero. We can do box plots, we can do histograms, we can do cumulative distributions. We cross that one off. And now if we go back to this graph one here, so that's just a label. What I'm really wanting, and I'm going to have to go back here actually. Just got a phone call there. So if I just go back here, I'm just looking for the actual one where I can graph. So if I click on Tmax and I hit graph, it's probably not going to do it for me. But really what I wanted to do, so it's got rainfall there now, but really what I wanted to do was show you the comparison between observed and generated data, which you can do, and I'd encourage you to do in these webinars. Well, not in the webinars, but before you actually use your data in DSSAT. So it's really important and really just good practice to have a look at your data before you use it in the model. So, and that's not just only modelling, but science in general, just as a sense check. So we'll cross that one off. We'll go back to the main interface. So we've done weather data. Now seasonal analysis actually runs the crop management information, so you can build in irrigation, nitrogen fertilizers, different crops, and I looked at that in a different webinar. So I'll just see if I can bring that up quickly now. If I go to open, we open up this one here, so you can see that it's the seasonal output file. We go open. You can see the treatments that we used, up to 7 treatments in this one, the number of reps, the crops, which stands for maize, as well as some other management and experimental details. Hit save. and then you've got your variables that were simulated there. So in this one, we'll just look at harvested yield. You could look at everything. We hit plot, and then you've got your different treatments. So note that the y-axis is not minimum there. And we've got your median, which is this yellow zone, and the 75th to 100th percentile is the blue, and you can see the differences between your treatments there, which is quite useful for looking at as well. Cross that one off. Now go back to, so we've got rotational analysis, and that's similar to the season analysis, so you can open that up and actually have a look at some of your individual sequence files. There's no examples. So I'm not going to go any further into that in the context of this webinar. Then you've got your genotype coefficient calculator. Now, as I said before at the start of this webinar, there's GenSelect and there's the glue estimator, which is in the accessories. So the key difference, you have to use that other accessories item before you actually use this GenSelect. So the purpose of this GenSelect is to specifically select your experiments and treatments for estimating your cultivar coefficients. So I'm not going to go into that here because we've probably gone for a long time already. Then if we go to accessories, now the introductory simulation is probably something that I should have pointed out at the start of the webinar. That's probably one of the best things to look at if you're a beginner. Look at that introductory simulation. It's got some really, really good examples. And that's quite similar to what I've shown before, so I'm not going to go into that. Then you've got your glue coefficient estimator. So you might say, well, what's the difference between that and the GenCalc? Well, so really what that does is it selects the appropriate experiments and treatments that you use in that GenCalc. Okay, so we'll cross that one off. Then we have the Easy Grapher. Now I must admit I've never used that. I tend to use the other graphing tool. Then we have the sensitivity analysis, and that in itself is quite a powerful functional tool as part of DSAT. So you've got your general components, you've got your genetics, you've got planting. So if we click on this, maybe let's click on this experiments one, and we select alfalfa here. Now it's probably going to pause for a second, and now we go to cultivar. So now that I've selected that experiment, now note that we've got alfalfa. If we change this one to barley here, you can see that there's different examples that come up. So if we select invalid source code, so if we select this top one, you can select them all. It's telling you the properties there, so crops, model, weather directory, and so on. Now you've got your genetics that are used in that file that I selected before. So let's hit Beecher and this Maris Badger one. If we click go, it will put them into your sensitivity analysis. So you've put all of those treatments from those two experiments to be used in your experiment. So the BAX stands for barley, but you can see all the different treatment details there, and they've come from these two here. If we hit create experiment, it's going to say, okay, where do you want to put it? It's in the default is into this sensitivity folder, which is part of DSAT. Hit save. Okay. Then you can view the experiment. Now it's got the experimental details, the notes, the treatments to be run, and that's just a standard notepad file. It's often useful to have a look at that first. Then you've got an analysis, well, which is saying we can't really plot anything without any data. We can run the model, and it's thinking, and it's thinking, and it's thinking, and it might go on thinking for the rest of this webinar because that's probably quite a big thing to do, so I probably should have checked that before I did it, but anyway, I've done it anyway. Now we go to view warning. Let's just have a quick look at what the warning is saying. Okay, so it's giving me all sorts of warnings there, and the reason for that is because I haven't fully checked it before I actually run the analysis. And then we can hit analysis. We've got all of the output files from the sensitivity analysis. Okay, so let's have a look at plant grow, which is an output file plot. And so this is using that GBuild graph builder that I mentioned earlier in the webinar. Okay, so we'll go plot. GBuild is already running, sorry, so it was in the background. So if we go to what I'm really looking for is yield, which is not there, but that's okay. Maybe we'll just go leaf area index. Okay, select all runs. Next. It's creating the data. It's actually quite a big file, so this is where you've got multiple treatments. This is where the GBuild comes in quite useful. And you can see that, well, around about 130, 135 days after planting, they're all peaking, and you can see the differences between the treatments, and they're all in the legend there. Okay, so we get rid of that one. Now, we'll just pop that down there, cancel that. And you can go into each of the components there, but as before, I'd encourage you to have a good look at that sensitivity analysis. It's a really useful feature. So we'll cross that off, go back to DSAT, and then we've got the weather analog. I won't go into that here, but what the weather analog does is if you've got 1 year, and let's say it's an atypical year, and you want to replicate that year or find sites with similar weather to that you've been using, it actually ingests them and picks and creates similar weather or similar years to that you've been simulating. So again, that's a very useful aspect, and you actually click the map for where you want it to be, and you can go into those details there. I don't want to save that. And so that's about it for the accessories. There's this utilities thing here, which is the configure, which as I mentioned before, the explorer, which brings up the pane, which basically shows you the whole layout. We've got the version info, which shows you when it's been updated. We have references there, which are PDFs for which you can go into, and shortcuts. So that's it. Thanks very much for watching, and see you next time.